Okay, so we are going to look at graphing sine and cosine functions today. You have a quiz tomorrow. It will not be over the graphing, but it will be over your special angle values, sine, cosine, tangent, even secant, cosecant, any of those. Just like has been on your last few tests, you're going to have another quiz tomorrow over the same sort of thing. Make sure you know how to do this. It's not going away. All right, so this is going on page 102 when we're done. We are going to graph. So we looked at the basic stuff yesterday from our, fettuccine and what happened when we unrolled it. Okay, so we got the sine and the cosine functions. And there's certain parts that we talked about. We'll have the definitions here in just a little bit, but the distance from, if there's no shift, it's from the x-axis to a maximum or minimum point, but really it's the half the distance between the maximum and minimums. This is called the amplitude. The length of one cycle, so a cycle for sine would be from here to here. This is a period. For cosine, we have the same thing. So this is the amplitude. And from here to here is a period. So remember, we talked about this yesterday, you can take the cosine function, and if you just shift it over pi halves, you end up with the sine function. So one is just a horizontal shift of the other. And so it says, notice that cosine function is a horizontal translation of the sine function. Any transformation of a sine function is called a sinusoid. Therefore, sine and cosine functions are called sinusoidal functions. And functions that repeat at regular intervals are called periodic functions. So they also fall into that category of periodic functions. Okay, so a period is the length of one cycle and it can start at any point on the graph. The easiest thing for us to do for sine and cosine is to start at 0 so that it makes the most sense. It'll make all the graphing a whole lot easier. The amplitude, remember, is half the distance between max and min values. Okay. Half the distance between max and min values. So yesterday when we looked at transformations, I gave you a big old long thing that had C and D in it as well. We're just graphing with A and B today. We'll add C and D tomorrow. So if all I have is A and B, remember A from all of the other transformations that we've done is your vertical stretch or compression. For sine and cosine, it's called the amplitude. But it's the same thing, still a vertical stretch or compression. It's the absolute value of A because the sine, the SIGN, does something else. The period for the parent function is 2 pi, but we have to divide it by B, so it's 2 pi divided by the absolute value of B. Okay. So the first thing we're going to do is just to identify the amplitude and the period of each function, which is like saying identify the vertical stretch or compression and the horizontal stretch or compression, which we've done 5 million times already. You've been doing since Algebra 1. So there is no A, or A is 1, basically, and so your amplitude is 1. The B is 4, so the period is 2 pi over 4, and when you reduce that, you get pi halves. Okay, so the period is pi halves, the amplitude is 1. For number 2, the amplitude is 7 halves. The B is 1, but the period then is 2 pi divided by 1, so it's 2 pi. So remember, your x-axis has pi's on it. Number 3, your amplitude is, this is a -5, but amplitude is 5 because it's the absolute value. The period, think about what the period would be. This is 1/3. period of the parent function is 2 pi, and we've got to take 2 pi and divide it by 1/3. That means we multiply by the reciprocal, so the period would be 6 pi. Number 4, the amplitude. Absolute value of -2, so it's 2. The period is going to be 2 pi divided by 4/3. Oops. Hang on. So 2 pi divided by 4/3, which means we multiply by the reciprocal, right? So 2 pi times 3/4, which is going to give me 3 pi over 2. The period is 3 pi over 2. Those are things we have to be able to identify. If we can identify those and we understand the parent function, then we're good. And the key here also is that if you do what I'm telling you to do, and that is the most important thing. Y'all are stubborn and don't want to draw some of the things I'm telling you to draw, and then I have no sympathy for you when you're confused. Okay? So it says identify the amplitude and period, then graph the function. All right, so for number 5, your amplitude is 2. The period, b is 1, so the period is 2 pi. Here's the part that you're going to be stubborn about, and you need to get over yourself because it's going to make a lot of what we do very difficult if you don't do it. I'm sketching the parent function. Very simply, this is what the parent function of sine looks like, just that one cycle. And you may feel like you don't necessarily need to do it on some of these, but when we start translating them, I'm telling you, you need that picture. So do it now. So you start at 0, 0. We are not shifting left, right, or up or down right now. We are just looking at amplitude and period. So 0, 0, this first point, it's not affected by the period and it's not affected by the amplitude. So we're starting at 0, 0. The next point you should plot is the end of your period. This is 2 pi. This is an intercept. So at 2 pi, I also have an intercept. The next thing you should do is the middle intercept because it's halfway. So halfway between 0 and 2 pi is at pi. The next thing you should do is your maximum. For the parent function, it's at 1, but the amplitude is 2, so halfway in between there, from the x-axis, I go up 2. Halfway in between here, I go down 2. So now I have my 5 anchor points. Then things just repeat. So I'm at 0, pi, and 2 pi for my intercept. So I should have 0, negative pi, negative 2 pi. Down, up, then this one's going to be down here, and this one's going to be up here, and then I sketch in my sine. Just like that. Okay. Now, you can't take forever drawing these. It cannot look like your pencil threw up on your paper, but they also don't have to be perfect works of art. Okay. All right, let's look at number 6, amplitude. Amplitude is 5. Think about what the period would be. The period is 2 pi divided by 1/2. If I divide by 1/2, I'm multiplying by 2, so it ends up being 4 pi. Then I draw in, or I sketch my little parent function for cosine. That first cycle looks like this. So for cosine, for sine, I had 3 intercepts, a maximum and a minimum. For cosine, I have 2 maximums, a minimum, and 2 intercepts that I'm going to go on here and plot. Okay, so my parent function starts at 0, 1. So when I start on the y-axis, I start at 0, but I'm not starting at 1 because my amplitude is 5. So I really start at 0, 5. That's this point right here. Okay, so then I want to plot the end of my cycle, or my period. But I can't because 4 pi is way off the graph. So I don't get to graph that one. But that's okay. Because the next thing I would want to do would be my minimum, which is halfway in between these two. Well, if I'm going from 0 to 4 pi, halfway is 2 pi. So this has an x value of 2 pi. It's a minimum, and my amplitude is 5. So at 2 pi, I go down to -5. halfway in between these, and I don't get to plot that point there either, but halfway in between these, I can plot an intercept. So halfway between 0 and 2 pi is pi, and I have an intercept there. So I get this part of the curve that I can graph right now. But then I can repeat it, right? So if I'm at 0, if at 0, 5 for a maximum, and 2 pi negative 5 for a minimum, then if I'm coming up, I've got to go back down. So I'm going to have a negative 2 pi negative 5. And halfway in between there's at pi, there's that. Everything is symmetric and everything repeats. Okay? So then you get this curve that looks something like this. There is 5 times the cosine of 1/2 x. Let's graph another. All right, so my amplitude is 3/2. The period is 2 pi divided by 4. That's going to reduce to pi halves. Okay, so that's my period. I then sketch in cosine. One cycle of cosine looks like that. I start here. It would be at 0, 1, but I have an amplitude of 3/2, so I'm actually at 1.5. The next point I do is the end of my cycle. The end of my cycle, oh, I messed that up. Look at this. This is at 3/2, but look what else we got. Oh, that's negative. So instead of being up here, this is a reflection. It's a reflection in the x-axis, so I shouldn't be at 0, 1.5. I should be at 0, negative 1.5. 0, negative 1.5. There we go. So that what was a maximum becomes a minimum. So this one that was a maximum is going to become another minimum, but it has to end at the end of the cycle. This is pi. Here's pi halves. I'm down here. Okay? So now I have these 2 points, which were maximums. They are now minimums. Then this right here, which was a minimum, is going to become a maximum, and it's halfway in between at 1.5. Then I have to get my intercepts, which are halfway in between those. So halfway in between these two on the axis is right there and right there. There are my 5 anchor points. Then it repeats. So, you want to go about these things kind of methodically. I would go and do the rest of my intercepts first because it's in the middle of every single one of these. So you can just go and put all these in there. And I know you're already whining. Your hand's not going to fall off. Just plot the dang points. Okay. Then you alternate, right? Up, down, up, down. So this was down. So this one's going to be up here. And then down here. And then up and down. Up and down and up. Or you can look at it as this is every other one this way, and then every other one down here. And when you draw these in, these are curvy. It's not a zigzag. There shouldn't be points anywhere, like pointies. So it's going to look like this. Curvy, curvy. Okay, so at any point, if you need to pause it to get caught up on the graph, do that. Or if you want to pause it to see if you could graph the next one on your own, that's not a bad idea either if you're feeling adventurous. So I would definitely try that so you're not just copying down everything that I'm doing. But I'm just going to keep moving through these. So number 8. Amplitude is 1, but I got to pay attention to the negative. The period, I'm going to take 2 pi, and I divide it by 8/3, which means I'm multiplying it by 3/8, okay, which is going to give me 3 pi over 4 as my period. I want to draw in, or sketch in here, sine. Sine looks like this. So I start at 0, 0. 0, 0 doesn't change. Then I need to put in the end of my period is the first thing that I do. It's at 3 pi fourths. All right, well, this is pi halves, this is pi fourths. So every single little space is pi fourths. So 1, 2, 3, this is 3 pi fourths. That's the end. Then I got to find this one. That's the middle. I got my 3 intercepts. Then I need to find this point. For my parent function, that is a maximum at 1. There's a reflection here because of this, and my amplitude is 1, so I'll actually be down at -1. I got to go halfway in between this. Okay, now this is, this is 3 pi fourths, so half of that's 3 pi eighths. So we're really looking for 3 pi sixteenths, but none of that matters, and we don't need to be doing t-charts. Think about it this way. This is like 1.5 spaces. It's like $1.50. Half of $1.50 is 75 cents. So I need to go 3/4 of the way. And then instead of at +1 because of the reflection, I'm down here at -1. And I'm 3/4 of the way in here and up here. Okay? And then once again, you just repeat. Okay? So I have this, and it's 1.5 away, 1.5, 1.5. So to get all these little intercepts in here, like so. And then this is up, so this is down, so this is up, so this is down, this is up, it's down, so this is up, down, up, down, up, down. And it looks like this. Okay. All right, number 9. Amplitude is 5 halves. The period, it's 2 pi divided by 3 halves. I'm sorry, it's 2 pi divided by 2/3, which I multiply by 3 halves, which gives me 3 pi. This is cosine. This is the parent function for cosine. Okay, so I start, my parent function is at 0, 1, but I have an amplitude of 5 halves, so that's really 2.5. But I also have a negative here, which is a reflection. So instead of at +2.5, I'm at -2.5. And there's my point. I need to put a point at the end of the cycle, the end of the period, but it's at that's at 3 pi, and it's off my graph. So this one's out. But I can maybe do what should have been a minimum, and it'll now be a maximum, because halfway between 0 and 3 pi is 3 pi halves. This is 3 pi halves, so that's going to give me a maximum of 2.5. So now I have these 2 points done. Halfway in between these two, so halfway between 0 and 3 pi halves is 3 pi fourths. You know how easy that is? 3 pi halves, halfway gives me 3 pi fourths, right? Dividing by 2 is the same as multiplying by 1/2. This is 3 pi fourths right here, and this is a 0. So it's going to look like this. Now I had to go 1, 2, 3 spaces, so I can go 1, 2, 3, and so when I'm coming back down, that point right there fits on the graph. Right? So when I'm coming back up and I need to hit the axis, I go 1, 2, 3 over, I'm right there. 1, 2, 3 over, and I'm up here at 2.5. 1, 2, 3 over, I'm back down here. It's a very repetitive periodic graph that's very symmetric, easy to count. Count, count, count. That's our goal right now. Okay. All right, last one. If you haven't paused and tried one on your own yet, you should try now. Amplitude is 4. The period is 2 pi divided by 2, so it's pi. I have my parent function that looks like this, right? And I'm going to start with this point. It's 0, 0. I put a point at the end of my cycle or end of the period, which is at pi. Then don't forget to do the one in the middle. And halfway in between is right here. So now I have my 3 intercepts. Then halfway in between these two, it's a maximum. There's no reflection, so it really is a maximum. My amplitude is 4. So halfway in between, I go up to 1, 2, 3, 4. Halfway in between these two, I go down 1, 2, 3, 4. There are my 5 anchor points. Then I can just repeat. I'm going to get all of my intercepts in there. Okay. Then in between here, I'm up. In between here, it's down. And then up, down, up, down, up, down. So my graph. Oops. Looks like this. Okay. And there we go. Now, on your assignment, there are 4 tangent graphs at the bottom. Don't even look at the tangent ones yet. We're going to talk about tangent tomorrow, but you should be able to get started on graphing the other ones. Get this glued or taped into your ISN. Ask the substitute for your assignment and get to work on it. Be good. Be at school tomorrow. Get some of these graphed. If you come with blank graphs tomorrow and no questions, I'm going to be mad at you. Graph.